Hi everybody, time for another teardown. This time we got some old vacuum tube equipment, and it is a PRD Electronics Incorporated Klystron power supply, model 809-A. And this is it right here. It's quite a heavy beast. I'll get a little bit more into what a Klystron power supply is in a minute, but this is something that I acquired a few years ago for free. And here we have a Lafayette PA645 audio amplifier that I also got for free way back in 2001. And the problem that I had with this is that it didn't have any of the power amplifier tubes in here. This requires some 6L6GB amplifier tubes, and it just so happened that this one happened to have some 6L6GC amplifier tubes in here, and these are the tubes that I took out of here already, so there won't be any surprises when I actually take this apart. I know what's inside, but there's the two tubes that I took out of there. I will pop them into this amplifier. Now this amplifier does work. I have used it with some 6L6GBs that someone has graciously given to me a while back, but those are, not a matched pair, and they're just, basically scrap tubes that just happen to be in somebody's collection. And so I really want to put, good quality matched pair 6L6s in here. And so that's why I'm just going to be scrapping this one for parts or anything else that we can find in here. Now, I did try actually selling this at a ham fest a while back, and there were no takers. I had it priced at like 40 or 50 bucks, and I thought that was reasonable, especially since it actually had a couple of 6L6GCs in there. These tubes alone are worth 40 or 50 bucks if they're a good quality matched pair. So I will be, putting these tubes into here, and we'll just take this thing apart and get some pieces out of it and see what kind of cool stuff we can find inside of it. Well, I guess I was mistaken about the tubes that were inside the amplifier here. It looks like that the guy who gave these to me sometime back in 2008, I think. Here they are. There's a GC and a GC, a couple of 6L6 GCs right here, but you can see that they're both in different glass envelopes, and we've got the getter is up here on the top of this one, whereas this one has two getters on the side. And let's see, this one, it just says Japan right here. There's not even any manufacturer's label at all. This one, at least, it has GE Electronic written on here, electronic tube from 1961 by the looks of it. But the two tubes that came out of the Klystron power supply, both 6L6GCs and both RCA electron tube, both from the exact same date code, and I also tested both of them on my TV7 D/U vacuum tube tester, and they both came out to pretty much the exact same number on the meter. And I know that's not a truly comprehensive test for matching vacuum tubes, but for me it's good enough. And there, I just put them back into the amplifier right there. This is the rectifier tube. There's a few more tubes in here, like a 12AX7 or something like that inside there. It actually has two different audio channels for the input, but only one mono output depending on the type of load. That's what all these different terminals are for like 4, 8, or 16, or 25, or 70 ohms is the kind of load that we can put on this thing. But if I ever do a video of this, that'll be in basically another video. Right now, we're going to focus more on the Klystron power supply. Now, you may be asking yourself, what the hell is a Klystron, and why do I need a special power supply for it? Basically, a klystron is a special type of vacuum tube that's used for the production and modulation of microwave RF signals. And compliments of Wikipedia, we've got this handy-dandy little schematic diagram of the very basics of what a klystron looks like. And that is, we have the cathode heated by a vacuum tube filament inside there, of course. And the cathode has a negative charge with respect to the accelerating grid, and so that's basically going to be called the beam voltage right here, and you can vary that on the power supply. And so you put many hundreds of volts on that beam voltage, and that accelerates the electrons coming off of this cathode, accelerates them up through the resonant cavity and up towards this repeller or reflector plate up here. That has a negative charge coming from this U2 coming over here, so that's going to repel the electrons back down towards the resonant cavity. And then we've got some weird physics going on here where the electrons bounce around at a certain frequency depending on the geometry of the cavity, and that could, be several hundred megahertz or up into the gigahertz range. And then that gets picked up by this little pickup loop right here, and that goes out to RF output terminal. Now that's just for the production of microwave frequencies, but in order to modulate it, you'd have to vary the U2 voltage or vary this resistance right here, or in any way possible. Basically, you want to put an AC signal on the DC bias that's already on the reflector plate in here. So that will vary the strength at which these electrons get repelled down into the resonant cavity. And then somehow that's going to have an effect on the strength of the microwave output from the pickup loop. Now, before I took those 6L6GC tubes out of this thing, I did actually get some very basic measurements out of it on the beam voltage right here. That's the main accelerating voltage for the electrons. We got 640 volts DC maximum, turning this knob, turning this pot all the way up to maximum. And then the reflector voltage, remember that was just for the reflector and also with some AC signal on the DC bias. So 920 volts DC and 55 volts AC RMS on top of that. And then, of course, there's the filament voltage, 3.4 volts on either side of the center tap. Now let's have a quick look at the controls. We can see that we can control the beam voltage to off, just turn the voltage output off, or we can look at voltage on the meter or current on the meter. The current is spec'd at a maximum of 65 milliamps right here for the beam power supply. And of course, vary that beam voltage right here with this knob. The reflector voltage is done with this nice knob right here, up to 900 volts on the dial right here. And then of course that is just the DC voltage. There's also all the AC modulation built up on top of that right down here, so we can vary the amplitude and the frequency of some built-in modulation right here. We've got square wave, we've got CW, and sawtooth already built into this device. Adjust the amplitude, adjust the frequency anywhere from where is it, 400 to 2000 cycles per second. And there's also the external point right here for external modulation input, so you can put any kind of signal you want in order to modulate the klystron. There's this round connector down here with 7 pins, and I don't have the probe or anything like that. I don't have a connector to plug into this. That might be one reason why I never actually sold it at this Hamfest, is because you know, the people realized that they would have to make some kind of special connector or their own connections in order to hook up into this thing, and it's just, you know, probably too much work for the price that I was charging. So it's still here, and I'm just gonna pop it open, and we'll see what's inside. Enough talking, let's see what we got. Here's the back of the unit. I've got the power cord already nicely wrapped up here, and pin out of the front connector. These two screws is what basically takes off the entire outside panel, outside case, and we'll just pop those out, and this thing is going to basically roll out of here real easy. Screws are out. Let's push it. Push it like salt and pepper. And there we go. Get this out of here. So we've got a real nice chassis inside, and the reason why I said it was gonna just roll out real easy is because it actually does have a little roller right here. There's a closer shot, just a little steel wheel right here, and that's supposed to be rolling on the inside of the case, rolling on this center metal bar right here. It just makes it a hell of a lot easier to pull it out of the metal case without any scraping metal pieces going inside there. It's really nice, very serviceable construction right there. And while we're looking at the bottom of the chassis right here, we can see we got a couple of transformers, and there's 5 octal vacuum tube sockets, and we got some high voltage capacitors in here too, some oil capacitors, and another smaller one right here rated for 1 or 0.1 microfarad and 1500 volt DC. Now here's the back of the unit. We got a nice little fan here with a simple shaded pole motor. Got to keep those tubes cool, you know. Got 200 watts of power just being pissed away with all these vacuum tube filaments. And there's the 2 empty sockets right here. Those are for the 6L6s that are already removed. And we've got a rectifier tube right here, the 5R4, and another rectifier tube right here, another 5R4, and then that one right back there in the middle, that's a 6AS7. I'm not sure what that is. Hold on a minute. Now here is a full complete schematic included in the manual for this thing, and it's got every tube, everything is all right here in this one picture. Now here you can see these are the 2 5Y4 rectifier tubes, each one on one of those 2 transformers that we saw in the bottom of the chassis. And here's the 2 6L6s, and you can see that they're hooked up in series cascade to handle the voltage requirements. Apparently the current requirements are a piece of cake for these things, but in order to get the 600 some odd volts out of here, then you need to put the 2 of them in series cascade like that. Now the 6AS7 is this thing right here, and just by looking at that, going over here we've got the reflector voltage. So this is probably going to be the main output power tube for the reflector voltage, and then the 6L6s, of course, those are for the beam voltage right there. Actually, the output of the beam voltage goes through this 1/16 amp fuse, and then through the switch right here, and then out to the connector. And this pot is just for the control of the beam voltage going through this 6AU6 vacuum tube right here, which then goes to the gates of the 2 6L6s. And all this other stuff down here, this is basically all the modulation and signal generation for a square wave or a sawtooth wave or whatever, and that all basically all feeds into the 6AS7. Again, that's just for the reflector voltage output. And pretty much all that circuitry that handles the modulation stuff, that's all on this circuit board right here. We actually do have some nice through-hole circuit board inside this thing. It's probably from the 70s by the looks of this whole thing, you know, late 60s at the earliest, or early 70s. And we saw earlier that there were very few point-to-point components soldered between the tube sockets down here. I mean, really, most of the electronics is all up here on the circuit board with the traces on the bottom side of it. And in fact, it looks like this thing must have been from 1968, because we've got some date codes right here. There's a 68 on this tube, the 6AU6, and we got our low power rectifier tube right here with another 68 date code, and of course the two 6L6s, they were also made in 68. And we've got capacitor right here with 6704, so 1967 of course for that thing. And so yeah, certainly late 60s is when this thing would have been produced. But then I probably can't pin it down that precisely, because we've got one of these capacitors here, the oil capacitor from 1964 by the looks of it. I mean, these things last pretty much forever, so 64 to 68 is not that big of a deal. If this thing was made with a 4-year-old or 5-year-old oil capacitor, that's nothing. But then there's this other capacitor right here, at least I think it's a capacitor. And it turns out this is not a capacitor. At first I thought that this was a date code right down here, the 23rd week of 1973, but it turns out that's a resistance. 732 with 3 more zeros after that. 732 kiloohms, and that's on the base for one of the 6L6s, and we can see it in the schematic right down here. There's a 6L6 pin 8 going over here to R105, 732 kiloohms. So I guess 1968 is a good enough estimate for the date of manufacture of this beast. And before I rip this thing to shreds, I wanted to just power it on one more time. Look at the nice warm fuzzy glow of all the vacuum tubes inside here. You can see all those filaments lit up. And we got some purplish argon glow. Oh, that was just the lens cap dangling, and it hit the fan blade spinning right here. But like I said, we've got some purplish orange glow right here from these vacuum tube regulators, voltage regulator tubes right there. There's another one with some purplish glow. And down on the bottom, there's the two, that's one of the voltage rectifiers, another rectifier tube right there, and the one in the middle, that's the 6AS7, and we can see some purplish glow right down there on the points of the mica wafer that's in there. Really weird. I don't know what would be causing something like that. I'm taking a closer look at that purple glow on this reflector voltage output tube, and I was poking around here with a screwdriver, and you can see the screwdriver is contacting the chassis, and just taking the tip of that screwdriver up along the glass envelope, and really doesn't seem to be having any significant effect here on the blue glow. And then occasionally, right where you see the tip of it pointed on the inside of the tube, I've been seeing some occasional flashes of light on the inside there. So I don't know, we got some weird stuff going on there. It might be something similar to the gaseous discharge that we saw in my Atwater Kent 55C AM vacuum tube radio that I looked at a while ago, and I made a couple videos for that, and I'll link that in, and you can see all the awesome and colorful destruction of that tube. I really don't know what's going on with this tube. Like I said, there were some flashes here. I don't know if I recorded any. Maybe I'll turn it off and then turn it back on and see what happens. A different view. Let's turn it on. Whoa, look at that. That is very similar indeed to the rectifier tube from that old AM radio. So maybe this particular tube does have some leakage inside there. There must be some kind of gas inside that's making that blue glow. And I think I see right there where the screwdriver is pointed, that little white point of light in there. That's some kind of undesirable discharge, or there, I think it's just disappearing right there. It's going away. So yeah, we got some weird stuff going on inside this tube. Now, is this the result of the fact that I don't have any of the 6L6s inside these other tube sockets? I really don't know. Maybe this kind of stuff wouldn't happen if I did have those tubes in place. But I think if this thing is actually acting like this, and that's just one more nail in the coffin for this whole thing as a whole, for me to take this apart. Not only is it giving me a couple of real good quality 6L6s, but it has some other problems that would need to be addressed as well if it was going to continue to be used as a Klystron power supply. And one more thing to note, and that is the power indicator lamp right here. It's a little saturated in the camera, but it's a nice red glow coming out of that thing. And then what's illuminating that is, of course, an incandescent light bulb right there, just suspended right there in the air, shining light all over the place, and only a tiny fraction of that light actually goes through the little the red filter in there going into the front panel. Now that light bulb is actually spec'd right here as this one, lamp incandescent, 0.15 amp and 5 volts, so that's 0.75 amp, 3/4 watt is actually what it's going to be rated for. 3/4 watt, let's just say 1 watt basically. Now that's, you know, by today's standards, absolutely horrendous that you'd be pissing away 1 watt just for an indicator lamp. But back in the day, 50 years ago, you'd be pissing away 200 watts just on all the vacuum tube filaments inside this thing. There's a lot of tubes, especially all up here on top, and then we got the power tubes down here with 2 or 3 amps going through each one of those filaments. A lot of power being wasted, and that's why this fan is even needed here in the first place, to keep all these tubes cool. So when you're pissing away 200 watts on all these tube filaments, then another 1 or 2 watts on an indicator lamp is really no big deal.